So continuing on with the solutions for the end of year review number 2, which is all about functions. We got through all the function properties ones, which take a little bit of a while just to write all these things down and explain what they are. But now we move on to some of the other stuff. If you want to get the domain and range of a relation, the domain is the x values. And so I just make a curly bracket. And my curly brackets are looking really bad today. Curly bracket. And you need to write down your x values, but do them from least to greatest, and don't put any repeats. So my lowest x value is negative 11. And then we have negative 2, negative 1, that shows up twice, you only have to write it once, and then 3. So those are those numbers. The range, squiggle bracket, let's see, the lowest number on this looks like 4, and then 5, 6, 7, and I believe that's it for, yep, okay, that's it. And ta-da, domain and range, x values, y values from least to greatest, no repeats. Is the relation a function? How do you know? Well, if you look at this, a relation is a function if each x value gets assigned exactly one y value. But something I noticed right here, negative 1, 5 and negative 1, 7, those are two different y values for a single input, negative 1, and so this one is no. And you can say negative 1 has two outputs or two assignments. I'll say two outputs. So that would be no on the function thing. Which of the relations in 1 through 3 is not a function? Well, that's actually really easy to look at. Number 3, if you do your vertical line test, which you can do everywhere, right here at x equals 4, there's multiple y values, and so it's going to be number 3 because x equals 4 has multiple y values. Or you could say it doesn't pass the vertical line test, which is exactly what that says, just in different words. Average rate of change between the points negative 1, negative 54, and 9, negative 12. Well, this one's actually a lot easier than figuring out from a table, but you subtract your y's. So if you take negative 12 and you subtract negative 54, and then you take 9 and you subtract negative 1, that gives you the average rate of change. It's just the slope between the two points. And so negative 12, 12, or negative 12, okay, negative 12, calculator's not working very well, minus negative 54, sending us negative 12 plus 54, which is going to be 42. And then 9 minus negative 1, same thing as 10, which would make this 4.2, or you can just leave it as 42 tenths. 8. What is the average rate of change over the given interval from negative 3 to 1? So negative 3 is right here, and 1's over here, and you get the average rate of change between those. Well, the function value up here is 9, so this is at negative 3, 9. And over here we have this point, which is at 1, 1. And so on this, your rise from 9 to 1 is going to give you 8. And then the run from negative 3 to 1 is negative 4. And 8 divided by negative 4 gives you negative 2. If my thing could write negative 2. Ta-da! Moving on to the next stuff. Given the function, evaluate f of negative 3. That means you need to take negative 3, and you need to put it in for all these x values here, and you put it in for both of them. So that's what we're going to do. Negative times negative 3 squared plus negative 3 plus 5. Remember, to follow your order of operations, you have to do the squared part. Well, you do parentheses first, but there's nothing going on in the parentheses, so now you have to do the exponents. So negative 3 squared is 9, and so we got negative times 9 plus negative 3, and then plus 5. Well, negative of positive 9 is just negative 9, plus negative 3 gives you negative 12. And you add the 5, and that's going to give you negative 7. Ta-da! And now we have another function, and we need to evaluate at 7 minus d. So right here, whatever you see in the parentheses is what's going to go in for the x. And so we have 2 times 7 minus d, and then minus 8. And now you just need to multiply that through, because we're trying to simplify it down. Make sure you simplify things if you can. You'll get 14 minus 2d, and then we got minus 8. These combine, and that'll give you 14 minus 8 is going to give you 6, and then the subtract 2d is still going to stay there. So subtract 2d. Man, my handwriting's atrocious. There we go. Not much better, but yeah. Moving on. So we have h and w. We have 2 function assignments. We need to complete h minus w and then parentheses x. Okay, what this says is you're going to take the function assignments and subtract them. This parenthesis x does not mean you times everything by x. It's h minus w of x. And so you're going to take your assignment for h, for x, and you're going to subtract your assignment for w, which is 9 minus 2x. And you can distribute that through, and then I'll give you left side 4x, it's just going to say 4x, minus 9 plus 2x. Combine your x's together, and I'll give you 6x minus 9. And so there's our first one. The next one, this is h times w of negative 2, which means we need times our function assignments together, so we need to do 4x times 9 minus 2x. We need to times that through, and once we've done that, let's see, we'll get a 36x minus 8x squared. Remember, x times x is x squared. And we need to take this negative 2 and put it in for the x's. So I'm going to get 36 times negative 2. That's really crappy, negative 2. Minus 8 times negative 2 squared. Well, negative 2 squared is just 4. 36 times negative 2 is negative 72. Minus, that's 4 right there, and 8 times 4 is 32. 32. Negative 72 minus 32 is going to give you negative 104. Ta-da! There's that one. Moving on, we have this function here on the left side, and we need to draw the transformations. This, so if you start with f of x, and then you change what's inside, it's going to move side to side, and you have to make sure you go the opposite direction that it says. So plus 3 would normally take you right 3, but since it's inside a function assignment, you're going to go left 3. And so I'm going to take this entire thing and just go left 3, and that's actually a little bit off the graph there. But here, let me put these points down, and one more to the right, and then down 3, right 1, and then over to, okay. Now I have my points connected up. Ta-da! I have now graphed it left 3. This next one, remember what's inside the parentheses is going to take it. You go the opposite direction. So plus 1 normally take things right, but you're going to go left 1, and then the subtract 3, since it's outside parentheses, you're just going to do what it says, which is go down 3. So I'm going to go left 1, down 3. It's going to take this one, this point there, and go right 2, and then right 2, up 2, right 1. And then down 3, right 1, right 2. Okay, so I got all my points. I'm just taking the exact starting shape and just going left 1, down 3, and get the new spot. And there are those ones. Let's see, next part, what do we have here? Oh, okay, we're going to have to do another video. Okay. We can answer these ones real quick, though. 15, if you transformed this vertically, negative 5 units, what the new y-intercept would be. Oh, the new y-intercept be? Well, the starting y-intercept is right here. This is a linear function, because it's something x plus a number on the end. No exponents or anything. So this is my starting y-intercept. If you go down 5, or you add -5, you're going to go down 5, you're going to get -3. So -3 would be my new y-intercept, so 0, -3. This guy, if you times it vertically plus 2 units, would be the new y-intercept. And this is not a linear function, and so -7 is not the y-intercept, but this naturally has a y-intercept at 1, because if you plug in 0, the y-intercept is y value when x is 0. The original y-intercept would be 1, and if you subtract 7 from that, you're going to get -6, and then if you add 2, you're going to get -4, which is at 0, -4, like this. And so let me just kind of explain what's going on. So 3 to the 0 power minus 7, and then you're going to add 2 to that. That's going to give you that. So this is the original y-intercept. Add the 2, you'll get -4. And there you go. And we'll stop the video there.